Question 17 says, check that the hypothesis of the Rolle's theorem for the following functions on the given intervals are satisfied. Then find the values, the value or the values C such that f prime of C is equal to 0. Okay. Like the first one. I think we won't do the easy ones. We'll do those that looks a bit hard. We'll do B and C from this part. So we'll go straight to the board. We need a bit of some space here. That's question 17. 17B. About the Rolle's theorem. Okay, so f of x is equal to sin x minus cos x. The interval is pi over 4 all the way up to 9 pi over 4. So what do you know about the Rolle's theorem? So the Rolle's theorem says that if f is continuous on a closed interval and differentiable on an open interval, then there should exist a C in between A and B such that f prime of C is equal to 0. So now if you look at this function is continuous on this closed interval there. And then the second thing we should look at is to check if f of A is equal to f of B equal to 0. So our f of A is f of pi over 4. So we get sine, pi over 4 minus cos pi over 4. Sine pi over 4 is root 2 over 2. Cos pi over 4 is root 2 over 2, which is 0. F of 9 pi over 4 will get sine it's always recorded, don't worry. So we'll have sine 9 pi over 4 minus cos 9 pi over 4. Also giving us root 2 over 2 minus root 2 over 2 equal to 0. So if you're not good at these angles, you can try to convert into degrees. Maybe you understand degrees well. So this will be 9 by 180 divided by 4. Okay, to be 9 by 180 divided by 4, which is 405. Then 405 is beyond 360. So when you subtract 360, it comes down to 45. So 9 pi over 4 is a coterminal angle 45. So we can use 45 and get zeros there. So now we've seen that f of a is equal to f of b, which is equal to 0. Then what next? We can go on and differentiate x. So we'll get cos x plus sin x. And then substitute, we put c and c there as we equate to 0. So now we need to find these values. So we'll have cos c equal to sin c. So where are these guys equal? They are equal in the first quadrant at 45. They are also equal in the second quadrant. They have different signs there. So what happened? Where did I find the minus? This is plus. Yeah, so it's going to be cos c equal to minus sin c. Yes. So now we're saying these guys are equal in the first quadrant. They have the same sign. So in the first quadrant, they are all positives. And also, they are all negatives in the third quadrant. But here, sin is positive, cos is negative. Cos is positive, sin is negative. So C will come from the second and the fourth quadrant. So it will be 45 in the second quadrant. What is 45 in the second quadrant? It's 180 minus 45, which will equal to 135. Or you can do pi over 180 if you want to convert it to, or let me just go straight and say pi minus pi over 4. So that I get 3 pi over 4. And then the other C will come from the third quadrant. I mean from the fourth quadrant, which will be 2 pi minus pi over 4, which is 7 pi over 4. And these two values, they fall in that interval. Remember, we always want A to be less than C, and this C should be less than B. So you check that these numbers are in the given interval. And for sure, they are. 3 pi over 4 is bigger than pi over 4, but less than 9 pi over 4. 7 pi over 4 is bigger than pi over 4 and less than 9 pi over 4. So now, for as long as you are going in a test, you should be equipped with the Rolle theorem because it's there in the test. That one is a must. And the most one that is likely is part C. Part C is f of x is equal to 2 to the power 2x plus 1 minus 3 multiplied by 2 to the power x plus 1. The interval is -1, 0. So this function is continuous because it's defined throughout in the interval -1 to 0. And then we check if f of -1 is equal to 0. That would be 2 to the power 2 minus 1 plus 1 minus 3, 2 minus 1 plus 1. This is going to be negative 2 plus 1. That's negative 1. And then minus 3. So I'm going to say, okay, let me first write it the way it is. And then plus 1. Then I write that this is 1 over 2 minus 3 over 2 plus 1. And this is 0. Okay. What about f of 0? F of 0 is 2 to the power 1 minus 3 plus 1, which is 0 as well. So we've seen that f of a is equal to f of b, and they're both equal to 0. Meaning we can go on and differentiate. So to differentiate f prime, remember the derivative of we're demonstrating the derivative of a to the power x, that you get a to the power x, and then a. We also demonstrate the derivative of a to the power u, that you would get the derivative of u multiplied by ln a multiplied by a to the power u. So here now we are in that system. So we'll differentiate the power for 2, this one. We differentiate the power, we'll get 2, and then multiply it by ln 2, and then 2 to the power 2x plus 1 minus 3 ln 2, and then 2 to the power x. And then we substitute c, because we want to solve f prime of c equal to 0. So we'll have 2 ln 2, 2c plus 1 minus 3 ln 2, 2 to the power c equal to 0. So ln 2 disappear. We remain with 2 to the power 2c plus 2 minus 3, 2 to the power c equal to 0. Like that. So we have 2 to the power 2, that is 4. And then 2 to the power c squared minus 3, 2 to the power c equal to 0. You see that, right? So what I've done there is we had the 2 to the power 1, and also 2 to this power. So since we have same base, we added the powers. So 1 plus 1 there becomes, yeah, and then from here 2 to the power 2c and 2 to the power 2. The 2 to the power 2 has become 4. And then the 2 to the power c can be written in brackets, and then the power goes outside the 2. So that now here we say, okay, let y be equal to 2 to the power c, so that we get 4y squared minus 3y is equal to 0. Fact out y, we have this 0. So y is 0, or y is 3 over 4. But what is y? Y is 2 to the power c, which is equal to 0. Not possible. And then 2 to the power c equal to 3 over 4. We apply ln on both sides. So we'll get C is equal to ln 3 over 4 divided by ln 2. So we need to check if this C is between that interval. It is. It's negative because the 3 over 4 is less than 1. Remember, I don't have to write because the graph of ln is like this, where this is 1. So if the number I have is between 0 and 1, 3 over 4 is between 0 and 1. So it's below the y-axis, and below the x-axis. So it means that it's negative. Then ln 2 is positive, since 2 is there. You see? So negative over positive is negative, and then ln 2 is bigger than ln 3 over 4. So that means that the number there is between -1 and 0. So it falls in the required interval. So that's our C. Next is question 18. What does it say? Verify the mean value theorem. Verify the mean value theorem. And after you have verified, what next? You do whatever you want to do. The mean value theorem for the following function on the given interval, then find the value. So the mean value theorem just need to check if it's continuous on that interval 1. Is it differentiable? 2. And then you get your f of A, get your f of B, and then get your B minus A, and then look for a C after you differentiate the function. So like function A. So here I think we'll do A and C. The function A doesn't look much complicated. Maybe it can fit here. So let's first differentiate it. F prime of x is going to be x minus 3 minus x plus 4 over x minus 3 squared. So here I've used quotient rule. So this means that we'll have 1 over x minus 3 squared. So let's get f of b. B is 6. So we'll get 2 over 3. And then f of A is 4. That would be 0. And then B minus A is 6 minus 4, which is 2. So what is f of B minus f of A? So first we take C in here. So we have 1 over C minus 3 squared is equal to f of B, which is 2 over 3, minus a 0 over 2. So this 2 and that 2 cancels. So we end up having 1 over C minus 3 squared equal to 1 over 3. So if we multiply throughout by 3, we're going to get c minus 3 squared equal to 3, meaning that c minus 3 is plus or minus root 3. That implies that c is equal to 3 plus or minus root 3. Now we check. The interval is 4 to 6. So if you subtract root 6 from 3 minus root 3, that will be less than 4. So the only c that qualifies is the 3 plus root 3. This is the one that jumps to the interval that is needed. So we throw away the other one because it does not qualify. Yeah. Okay. So would have loved to continue. So I think I'll just guide you that you do the same for B and C. I'm supposed to have a class with the first years at exactly 22:30. Now, since when I cut it needs 10 minutes, then I'll have to cut here. Good night.